Okay, so chapter 6.1 or lesson 6.1 and 6.2 talk about a couple of things that are called the law of sines and law of cosines. And we're going to talk about law of sines today, and we're going to see how this is something that can help us out beyond what we were able to do in chapter 4. And then next class, if you remember during chapter 4, there were a couple of problems where we said, okay, based on what we know right now, using right triangles, we were trying to solve the application problem. But we're going to come back to a couple of those and show you how law of sines and law of cosines can actually make solving the problem easier and show you how you can do it this other way. Okay? So, we're starting off with this idea that we want to be able to solve a triangle. So what do you think it means when I say we want to solve a triangle? Any ideas? What do you think I'm asking you to do if I ask you to solve a triangle? Find the length of all the sides and all the angles. So basically a triangle has 3 sides and 3 angles to it, 6 parts to it. When I ask you to solve a triangle, we're saying find the missing parts. So what normally happens is that the problem is going to give you 3 of those pieces, and you then have to figure out the other 3 based on whatever information you're given. So in this case, we're being given there we go. We're being given actually 2 angles here because the box is telling us that's a 90-degree angle. Then we've got 52-degree angle up here. And then we're being told this one side is 14 degrees, or 14 centimeters, excuse me. So how could I figure out this angle? (90 minus 52), and what's 90 minus 52 going to be? 38. Okay, so going back to just good old-fashioned geometry stuff, we know that all of the angles of a triangle have to add up to 180. So if we have 2 of the angles, we can pretty easily figure out the 3rd one just by subtracting. Okay, how about this side? How am I going to figure out that side? Tangent of 38 has to be equal to what? The unknown over 14. So because we have a right triangle that we're trying to solve, we can use right triangle trigonometry to find missing pieces. So if we take the tangent of 38 and multiply it by 14, then what do we get for this side? Make sure you're in degree mode. How much? 10.93. Agree? Is that what everybody's getting? Okay. And then last but not least, if we want the hypotenuse, how are we going to find the hypotenuse? It's one possibility. There's lots of different ones. What's one possibility? We could take Pythagorean. Now that we know 14 and 10.93, we could get it that way. What's another possibility? We could do cosine of 38 and say that that has to be 14 over x. We could do sine of 52 and say it's 14 over x. So there's lots of different possibilities there. So pick one and find our... What do you get? 17. So everybody's getting about 17? Okay. So that's what we mean when we say solve a triangle. We were given 3 of the pieces, we have to figure out the other 3 pieces, which on a right triangle is pretty easy. But what happens when I give you information like this about your triangle? So we're being told here that we've got capital C equal to 103, capital B equal to 28, and small b equal to 26. What do you suppose is the difference between the capitals and the lowercase?
The capitals are degrees.
Right. Capitals are degrees, so that means they're going to represent the angles. And then lowercase are not degrees, so they're going to represent the sides. Okay? So we're being told here that angle C is 103 degrees, angle B is 28 degrees, and side B is 26. So how do I know where those things are supposed to be on a triangle? Well, if you draw yourself a quick sketch, and it really doesn't have to be the most accurate thing in the world, it's really just for reference. I can label my vertices pretty much any way I want to. So A, B, and C. But then the key is that the side with the same letter has to be opposite the angle. So if I want side B to be 26, I have to go opposite of angle B and make this one the 26. Okay? So side A is going to be here, and side C is going to be here. Okay, so it doesn't really matter where you start out by labeling your vertices for your angles, but it does then matter where you label your sides in respect to that. Okay? And so now if I label the things that I know, I've got this angle right here at 103. I've got this angle right here at 28, and then the 26 for that side. Okay? So how are we going to solve this one? I mean, if you sort of set up, and this is how I do things because I need to keep things organized. So I set up sort of a column with my 3 angles and then a column with my 3 sides. And I put my A across from A and my B across from B and my C across from C. And I fill in the things that I know. So 103 here, and 28 there, and 26 there. So then it becomes obvious which things I need to find. And as I start finding them, if I just keep filling in the spots, then I know what's still left and I know when I'm done, when I found everything. So what would be maybe the easiest thing to find first?
Capital A.
Capital A. So how am I going to find capital A?
Subtract 103 and 28 from 180.
Okay. Because again, any triangle has to have 180 degrees total for their angles. So if I know 2 of them, I should be able to find the third one by subtracting. And what does that end up being? 49. Okay, so there's my first piece. Now, what about the 2 sides, side A and side C? How are we going to find those? Can I set up a trig ratio? Can I do opposite over hypotenuse or adjacent over opposite or anything like that? No, because this isn't a right triangle anymore. So the right triangle trig ratios don't work in this case. So we need a plan B. And that's where the law of sines comes in. So the law of sines and the law of cosines, when we talk about that next class, are statements, properties, characteristics, I guess, that hold true for any triangles. It's not like right triangle trig where we can only do it with right triangles. Law of sines and law of cosines works for any triangles. Okay? So the law of sines says that if we've labeled our triangle with our angles, and then across is where our corresponding sides are, that it has to be true that if I take the sine of angle A and make a ratio of it with side A, that ratio has to be equivalent for every sine of an angle over a corresponding side that I do. So sine of A over A has to be an equivalent ratio to the sine of B over B, which has to be an equivalent ratio to the sine of C over C. That ratio of taking the sine of your angle over the corresponding side has to be equivalent throughout your entire triangle. So what that means is, if I can find an angle and a side that are across from each other that I know, then I can set up what that ratio is supposed to be. And then I can set it equal to another ratio where I only know one of those two pieces, and then solve the proportion. Okay? So if we go back to this problem, if I now want to look for side A, I start by setting up the first ratio using the sine of the 28 degrees and putting it over the 26, because that's an angle and a side that are across from each other that I already know. So that sets up what the ratio has to be equivalent to. Okay? And then I set it equal to a second ratio to make the proportion so that I can then solve the proportion. So in order to find side A, I would set up the second ratio as the sine of the 49, which is angle A, and then just put that over side A, and now solve the proportion for A. Does that make sense? So even though they're giving you these three different ratios, our task really is to take two of them and set them up in a proportion. And within that proportion, if only one variable exists, we should be able to solve for that variable. Okay? The other thing to notice here is that because we are talking about ratios, it doesn't matter whether I put the sine of the angle on top and the side on the bottom, or whether I flip it over and do the side on top and the sine of the angle on the bottom, as long as I do it the same way in both of my ratios. So it doesn't matter which way we do it, as long as we stay consistent. Okay? So now how do we solve this proportion? We cross multiply. So we're going to have to take 26 times the sine of 49, and then that has to be equal to the A times the sine of 28. So to get A by itself, we're going to take the 26 times sine 49 and then divide by the sine of 28 in order to get A. So first of all, make sure you're in degrees, so this will all work out. And then take 26 times sine of 49 divided by the sine of 28. We get
41.8.
So, but quite often, the answers you're going to get here are not going to be nice, even, pretty answers. So usually one or two places is fine. And basically just whatever you decide, be consistent. So if you decide to round to one place for side A, then round to one place for side C. If you're going to round to 2 places for side A, then round to 2 places for side C. Just be consistent. Okay? All right, so that gets me a second piece. I've got side A now. What about side C? Can I just use Pythagorean? No, because remember, Pythagorean, again, only works for right triangles. I don't have a right triangle. So I'm going to have to set up a second proportion to be able to find side C. So, let me find a color here I haven't used yet. So we can start out with our sine of 28 over 26 again. Right, because that one set what the ratio is supposed to be. But now I'm going to set it equal to the sine of 103 over my missing C side. So now solve for that one. So what's C going to be?
54.0.
And we want that point O, even though we rounded off to that, because again, if I rounded to the 10th place for side A, I want to show that I rounded to the 10th place for side C, even though it ends up being a 0. Okay, keeping the 0 there shows other people that this is the place I rounded to. Okay, and so now we've solved our triangle. We were given 3 pieces, we have figured out the other 3 pieces, triangle solved. Questions on that? Does that make sense? All right. Try one more on your own this time. What I recommend with these, I recommend that you do the ABC setup, because I think it just helps to kind of keep things organized and know what you're given and then what you have to find. If you need the picture, then draw the picture as well. The picture is not so much a requirement as just if you're not really sure what you're looking at or how the sides and the angles are related to each other, draw yourself a picture. But if you can figure it out just by doing the ABC, that's fine.
Assume that it's not a right triangle.
Oh, well, you have to decide.
Oh, 55.
I'm going to guess it's not a right triangle with those angles, but you have
Are we
to
ever
decide.
going to get triangle
You might. And if you do, then you can go to right triangle trig stuff. But if it's not, then Okay, think you got them? Alright, Bahar, what'd you find first?
I found angle B first.
Okay, and how'd you do it?
I just added 55 and 82 and subtracted it by 180.
So 55 and 82 gives us
137.
okay, and when you subtract them, you get
43.
43. Alright, so angle B is 43 degrees. Please make sure you put degree signs on them. These are not radian measures, so make sure that you're putting degree signs on those angles. Okay? Olivia, what'd you find next?
I'm still looking. Finding. Found angle B.
Angle B? We just found angle B.
Side B.
Side B, okay? What'd you do to find side B?
I did like sine 55 degrees divided by 8 equals to sine 43 divided by 8. And then find B is cross multiplication.
And then what?
And then find B cross multiplication.
Okay, and did you find that already?
Yeah, I got 6.7.
6.7? You agree with that? That sound about right, everybody? Okay. So again, as long as I've got angle A and side A across from each other, and those are two that I know, then I can set up the first ratio that tells me here's what the ratio has to be equivalent to, and then set up the second ratio to actually find my missing side. All right, so side C is left. Ethan, how'd you find side C?
Sine 55 degrees over 8 equals sine 82 degrees over C.
Sine 55 over 8 equals sine 82 over C,
I got 9.67.
9.67.
Yeah.
So if we keep consistent with what we had before, let's make it 0.7. All right. Okay, make sense? Any questions about that? Also, just a little quick check, I guess. Notice which of my angles is the biggest angle? C. Which of my sides was the longest side? C. Which one's the smallest angle? B. Which one was the shortest side? B. So there has to be that relationship. Your longest side has to be across from your biggest angle, always. And so if you just do a quick check when you're done that makes sense, it's kind of a good way to check any silly mistakes. Okay? All right, so this works great when we're talking about situations where we have two angles and an unincluded side, or two angles and an included side. Remember those letters from Geo days? The AAS, the ASA. Law of sines is awesome for those situations. Okay? It also works in the naughty one that you weren't allowed to use in Geo when you talked about congruence. When dealing with congruence, you can't use the SSA. And yes, we call it the SSA because this is a Christian school and we're good boys and girls. So when you were dealing with congruence, SSA was not allowed. That was not a way to tell whether your triangles were going to be congruent or not. But when we're talking about solving triangles, SSA is a possible combination of information you might get. And the law of sines is also going to be used to help you solve an SSA triangle, but it doesn't fit quite as nicely. Like AAS and ASA, they're beautiful fits. Like they're awesome. It's just practically there, hand given to you. Like, here, use law of sines. Okay, no problem. But when you start talking about SSA, we get into something called the ambiguous case of the law of signs. And the reason it's ambiguous is because when you get an SSA, there are different possibilities as to what might be happening with your triangle, and therefore what kind of answers you might get. So I want to take a little bit of time now and actually go through what those possibilities are and how you know which of those possibilities you're dealing with from situation to situation. So to do this, I want to kind of work through a quick little activity. And I want it to be something that you're kind of playing along with, so to speak. So I have these baskets here that have a couple of materials in them to use. I'd kind of like to go 2, 2, and 2. So would one of you guys mind coming over and working with Bahar so that she has a partner? Would that be okay? Thank you. So in the baskets, you're going to find 2 sheets of paper. You're going to find a ruler, a protractor, and then 2 pieces of string covered in wax, basically, is what they are. They're called wiki sticks. Any of you ever seen wiki sticks before?
Yeah.
Okay, so they're literally just like twine that's been covered in different colored wax, which means that if they warm up just a little bit, they get kind of sticky. So you can actually stick them to your paper and they'll stay put. Okay, so you should have 2 wiki sticks, a ruler, a protractor, and 2 pieces of paper. Anybody not have any of those pieces? Okay, so for the moment, just take 1 piece of paper. You're both going to work on the same page. Okay, set the other piece aside for a moment. And what we're going to do here is I'm going to go through a few steps with you and ask you to do some things so that you get to kind of play with your wiki sticks and play around with what the possibilities are. And then we'll talk about, like, so what happened in this case, and what happened in this case, and what happened in this case. So you start to see what the different possibilities are. Okay? So, paper with a ray on it. That's your piece of paper. You're just using 1 for right now. You've got the ruler, the protractor, the 2 wiki sticks, and something to write with. Yes? We're good? All right, so here's your first direction. I didn't give you scissors, so instead of cutting it, just bend it. So measure out 10 centimeters. And then wherever that is, just bend your wiki stick at that point and smush it together. So it's going to be 10 centimeters long. Okay? And then on your paper, with your protractor, measure an acute angle, any size that you want. It just needs to be acute. And then use your 10 centimeter wiki stick here to put down where that angle is. So you're measuring, you want to know what your actual angle is. So you need to measure an angle and then put the wiki stick down to form the other side of your angle with that measurement.
So this should be here.
No, this is just going to get smushed down, so it's just one side. So on your other ray is on your paper,
Oh.
right? So you guys are going to work together on that same paper. You want to use the end point of the ray as your vertex. So make sure you're setting it up correctly. Measure from there, and then use the end point of the ray as the vertex for your angle. And then use your wiki stick to actually stick it in place to create that measurement of angle. Does that make sense? And I would suggest ray on the bottom for what we're going to do. It's going to make more sense. that the end point of your ray? Come on. Okay, so did you measure out so you know how big your acute angle is? Okay, and you need to just write off to the side or write in the inside of the angle itself what that measurement is, because we're going to need to know that in a minute. Okay, everybody got it? So for my example, I've chosen a 40-degree angle. Okay, so here's my other side. Here's, excuse me, here's the ray that's on the paper. And I've labeled the 40 degrees inside there. Okay, you can have whatever measurement you want, just as long as it's acute. Okay, so now on your paper, with your wiki stick stuck to it, label the vertex as angle A, and measure the wiki stick as being side B. Okay, so the vertex is going to be angle A, the wiki stick is side B. And then from the free endpoint of side B, draw a perpendicular segment down to the ray on the paper and draw it as a dotted line. This is going to end up being the height of whatever triangle we create, so label it H.
Which one is the vertex?
You did not just ask me that. The vertex of an angle? Really? You just asked me where the vertex was?
I know it's the highest one.
The vertex? The vertex is just here.
Yeah.
Right? It's where the two come together. So I'm saying on the other end of that, the free endpoint, right? Then you're going to draw this perpendicular down and label that H, because that's going to be the height of any triangle we create. And so this vertex down here is going to be your angle A. Okay. Okay, everybody got that? So it should look something like this, right? So you've got angle A down here. You've labeled this as side B, which should be your 10 centimeter wiki stick, and you've drawn this line down and labeled it H. Okay, got it? All right. So to find H, because we've just created a right triangle, we can use right triangle trigonometry to come up with a measurement for H. So if the sine of an angle is opposite over hypotenuse, then in our context, that means that the sine of A should be H over B. Right? Which means that if I wanted to find H, it would mean multiplying both sides by B. So I end up with this equation where H, the height of my triangle, whatever it's going to be, is equal to B times the sine of A. So in my situation, that would mean taking 10, which is our side B, times the sine of 40 degrees, because that's the angle that I measured for angle A, and I get about 6.42 centimeters. I want you to figure out the H for your pictures, and then write it off to the side somewhere, because you need to know that a little bit later as well. So take B times the sine of A, figure out what your H value is going to be, and write it off to the side somewhere. Okay, got your measurements? Okay, you guys got it? You guys got H? You guys got H? Alright. Okay, so take the other wiki stick now. Leave side B stuck there. Take the other wiki stick and fold it so that it is shorter than whatever h is. And then connect it to the free endpoint of side B. Since that now becomes the side that's opposite angle A, it becomes side A. And I want you to try to position side A to see how many triangles you can make with that length of a side. Everybody understand what I'm asking you for? So fold your wiki stick so that it's shorter than H. Attach it to the free end of side B. And then see how many triangles you can make with that length of a side.
Oh. How big is the big part? Sure. It just
Was it shorter?
Shorter than H, it becomes your side A. I want to know how many triangles you can make with that length. Okay, so how many did you guys make? None? How many did you guys make, Casey? None? How many did you guys make? One?
What?
Did you fold your wiki stick so that it's shorter than H?
Wait, it's not shorter than H. Shorter than H.
Shorter than H. Should I speak more slowly? All right. So if you have a distance that's shorter than H, no matter where you try to put it, it's never going to reach the other ray, right? So here's a situation where we can't make any triangles out of it, right? So even though I may know side B, and they tell me a side A, and they tell me this unincluded angle, that doesn't guarantee that it really makes a triangle. Okay? So that's one possible scenario of what could happen with an SSA. The two sides and the unincluded angle they give you may not even make a triangle. And if that's the case, then there's nothing to solve. So if you were given a problem that had this situation, excuse me, you would just say no triangle and move on to the next problem because there's nothing to solve. Okay? So that's one possibility. Next possibility. Take your side A, okay, that wiki stick, side A, and this time refold it so that it is equal to H, as best as you can. Connect it to the free endpoint of side B and see how many triangles you can make out of that.
Trust in your calculations.
Okay, how many did you guys get? One, Casey?
One.
Hagen? How many did you get? One. Okay? So if my distance is actually the same as H, I can make this one triangle that actually is a right triangle, but moving it around to any other position, again, it doesn't reach the other side. So there's one possibility with this, which is great because if there's only one possible triangle, then I just go ahead and solve that triangle like we did with the other examples and everything's good. Okay? So that's scenario number 2. Scenario number 3. Take your side A again, and this time unfold it so that your wiki stick is actually longer than side B. So we're not comparing to H this time, we're comparing to side B. So if you unfold the wiki stick, it should be longer than B. Okay? Connect that to the free endpoint of side B and see how many triangles you can make of that. Now you'll notice here it says you may have to imagine that the ray continues beyond your paper because depending on how long your wiki stick is and what your angle was, you may run off your paper. But that's why there's an arrow at the end of your ray. It means it actually continues, so just pretend it continues on and how many can you make?
Yeah, it is on. Wait, so,
Well, because if you designate like
if you guys like again, as the builder, if it's a song.
oh, so let's say it's 7, right? Let's say it's 7. So it can't be any other triangle other than the distance of 7, 7. So it can only be 2.
What do you say?
Like if you made 7 centimeters,
H.
yeah, is that what it means?
No, we're making this.
Longer than B.
We're making this
Oh.
longer than this. So
Longer than
it could
B.
be as
Longer than
it could be
B.
like here, here, here.
Alright, Casey, how many did you guys get? 1? Guys?
I think there's a lot.
You think there's a lot?
One.
1? Why do you think there's a lot?
Oh, because I just thought you could keep on. Oh, yeah, but like, yeah.
But then would it still be that length, right? So if I use this one, yes, it crosses this, but it's no longer a side of that length that was bigger than 10 necessarily, right?
Yeah.
So the only one that actually works with that length is this one out here. If we tried to put it on this side, I don't know if any of you tried that, but if we tried to put it on this side to make a triangle, then this 40-degree angle, which we're saying is one of the things we were given, so it has to be that angle, would no longer be inside the triangle you create. So we can't think about, oh, well, let's just go on this side and make another one, because then that 40 degrees or whatever your angle is not inside your triangle anymore. So there really is only one possibility for this as well. So again, that's good. If there's only one possibility, we just set it up and we solve it just like we did with our previous examples. So far we've seen 3 scenarios. 1 where there's been no triangle, and 2 where just one triangle is created, which is cool. We just set it up that way. All right, now, take your side A again, and this time I want you to fold it so that it is longer than H, but shorter than B. Okay, so it's got to be in between those two. Longer than H, but shorter than B. And then connect that to your free side and see how many triangles you can make with that one.
Because it's shorter than B. What's possible?
Well, you can do, yeah. So you can do that.
All right.
Those.
How many? 2. How many? How many?
If you go on the inside.
Oh. So here's the crazy one. If what we get for the second side is something that's between H and B, then there's actually 2 different possible triangles that could be made. And since there's nothing else usually given to us about the triangle other than here's an angle, here's a side, then there's no indication as to which one they're actually talking about. So guess what? we have to solve both. So when you get this situation where you end up with that opposite side from your angle A being somewhere between H and B, you're going to have two sets of ABC, ABC, because there's two different possible triangles that you can solve. In the one triangle, if we're looking at this one, okay, then the angle here is going to be an acute angle. Okay? But if we're making this one, then the angle across here is obtuse. Okay? So what ends up happening then is if you're trying to solve the two different triangles, knowing that in one case this angle across from side B, so that would be the first one you'd look for because you have the side to go with it. In one case this angle is going to be acute, in the other case this angle is going to be obtuse. So when you set up the law of sines and you take inverse sines, what two quadrants are we allowed to get an answer in for inverse sine? You just had a test on this. What two quadrants are we allowed to get an answer in for inverse sine? 1 and 4. Okay? Is it going to make sense to get a negative answer from quadrant 4? No. So that means we're pretty much going to get a first quadrant answer. That takes care of the acute. First quadrant is acute angles. So when we work out the proportion and we push the buttons, the calculator is going to spit out what this acute angle should be. Okay? In order to figure out this angle, we're going to take 180 minus that acute angle. Because if you think about it, both the blue and the purple represent the same distance, right? Which means if you look at just this triangle right here, we're looking at an isosceles triangle. So whatever this angle is also what this angle is. Those two are the same. So in order to get the angle on the other side that I want, I would just take 180 minus that to get the obtuse angle possibility. So for one of the triangles, you're going to set up the proportion, solve it out like you normally do, get the acute angle answer. And then in the other triangle, for that same angle B, you're going to take 180 minus this one to get that one. And then you just finish solving each one with the set of numbers you have in each one separately. We'll show you an example of that in a little bit. Does that make sense? So this one's the tricky one, because if you're not paying attention and you don't realize you're working with a situation where there's two possible triangles and then you only give me one, you've just lost half your points because you didn't give me the second one that was possible. So you've got to make sure you're paying attention to what's going on with these. All right, so 4 scenarios we've looked at so far, and in all of them, we were dealing with an acute angle. Okay, and we've looked at all the possibilities with an acute angle. But now what happens if we have an obtuse angle? So now, take off your side A, but then also take your side B and change it so that you create an obtuse angle. Now we don't have to care too much about what that angle actually is, so just place it somewhere so that angle B now is making an obtuse angle with the ray. Okay, got obtuses? Alright. Alright, so now take that same side A that you were just using and put it on the end of side B now. And see how many triangles you can make. Alright, so how many did you guys make? None? Casey?
0.
0? You sure? Alright, so now with an obtuse angle, if we have a side, that second side is something smaller than B, then again we have that situation where there's no way it's going to reach over here to the other ray. So when the opposite side is smaller than the adjacent side with an obtuse angle, then we know we have no triangles. So again, you just write no triangle and you move on to the next problem. Alright, so unfold your side A again so that it's longer than B. Last one. Connect that one, see how many triangles you can make.
Side A. Side A is this. Oh, it's not
So how many did you get, guys? One? One? You got two?
Actually, no, 1, because the ray is next to it.
Okay.
the ray. Oh, yeah.
So if I have something longer than B, I can make the one out here. Remember, we're not going to go this way because then this obtuse angle we're talking about isn't in our triangle anymore. So coming this way, there's only one possibility, and so there's one possible triangle there. So again, you would just go about solving it like you normally would. So 6 different scenarios that could possibly happen when you have an SSA. That's why it's a naughty little triangle. Because it gives you 6 different possibilities of what could happen depending on what those measurements actually are. Okay? 4 of them depend on having an acute angle given to you. 2 of them depend on having an obtuse angle given to you. So that's usually the first thing you look at, is what's the angle I'm given? Is it acute or is it obtuse? Once you decide that, if it's obtuse, it's pretty easy. You just have to decide, is that opposite side from the angle they give me bigger than or smaller than this acute or this adjacent side? If it's bigger, then I work out the triangle like I normally do. If it's smaller, there's no triangle anyway, I move on. But if it's acute, the first thing to look for is, again, is that opposite side going to be longer than the adjacent? Because if it is, there's one triangle, I just go ahead and do it. If it's not, then you have to find H. And then you have to make the comparison to H. If you're smaller than H, no triangle. If you're equal to H, one triangle. Solve it like you normally would. If it's between H and B, then that's when you get the weird 2 triangle possibility. And you've got to solve both. Okay? So, on the papers, on the back side, now you can each have your own paper. On the back side, you get a table that looks something like this. So this summarizes for you all 6 possibilities of what can happen. You've got the 4 possibilities when A is acute. You've got the 2 possibilities when A is obtuse. Okay? So, you've got little pictures here to remind you of what the situation looks like. And then you've just got written out in inequalities the condition we're talking about. So again, just a really quick recap. If A is less than H, then how many triangles do we get? How many? 0. Okay, when A is less than H and we have an acute angle, no triangles. Acute angle, but A is equal to H? 1. An acute angle, but A is bigger than B? That's 1. An acute angle with A between H and B?
2.
That's the weird one. That's 2. Okay? And then an obtuse angle where A is less than or equal to B? That's none. And an obtuse angle where A is greater than B is 1. Okay? So, let me give you a quick example. Let's say that I want you to solve a triangle that has an A of 35 degrees, side A is 12, and side B is 14. So the first thing you always need to ask yourself before you go into all of this is this an SSA? Because the ambiguous case with these 6 different possibilities is only with an SSA triangle.
What's an SSA? It's
Side angle, but the angle is not included. So the 2 sides are not making that angle. It's one of the other angles. Okay? So is this SSA?
No.
Yes, I'm giving you 2 sides and a non-included angle. So decide which of the 6 scenarios we're dealing with here.
How would you know?
triangle.
So what would you look at first to decide?
Cube.
Oh, it's
The fact that it's an acute angle. So that takes off the 2 obtuse angle possibilities, right? Because the A that we're given is acute. So that narrows us down to the 4 acute. Okay? The first one I would check is the side opposite your angle longer than the adjacent? So if you need to, there's 2 ways to do this. We can set up our little grid here and fill in the 35 and the 12 and the 14, right? So the opposite side is fairly obvious here because we can see which angle and which side are opposite each other. So the first question is the opposite side going to be bigger than the adjacent side? Is it? Is opposite side bigger than the adjacent side? No. So that takes care of the A greater than B scenario. It's not that one. So now we're down to 3. And in each of those other 3, what do we have to know to decide which one we're talking about? The H. So we're going to have to figure out H. How do I figure out H?
Opposite of sine 35 equals O over 14.
So what would be the O in this scenario? Nope, the height is the H. Oh, wait a minute, say what you said again.
Sine 35 equals to O over 14.
Over 14, okay, that works, sorry. It didn't process what you said until a few seconds later. So when we talk about, the little formula we came up with was H equals B sine A. B always represents the adjacent side, the one not opposite our angle. Okay? So 14 is the one that's not opposite, and then we take that times sine 35. So what does that end up giving us? How much? 8. Okay? So now we have to compare A to H. Is A smaller than, equal to, or bigger than H? Bigger. So what scenario, how many triangles should we expect if I have an A value that is bigger than H but smaller than B? That's the 2. Okay? So what that means is I'm going to set up another set of AB and ABC and ABC, and I'm going to fill in the exact same measurements that were given to start with. Alright, so let's talk about the blue set here. What's the first thing we should find? What's the first thing we can find? Angle B. Because I have A across from A, so that's going to set up one ratio for me. And then I have side B, so I can find the angle across, which would be angle B. Excuse me. So I'm going to take the sine of the 35 over the 12 and set that equal to the sine of angle B over the 14. So now when I go to solve this, notice that I'm going to end up taking 14 times the sine of 35 and divide it by 12. But what's that going to be equal to? I take 14 times sine of 35 and divide by 12. What's that equal to? The sine of B. So to actually get B, I then have to do inverse sine of that result. And so you'll end up with a B value of what? About 42. Everybody else getting that? 42 sound right? Yeah? Okay. So, in one triangle, that opposite angle from side B is going to be 42. That's the acute one. But then in the other triangle, it's that same angle B that's going to be the obtuse angle. And so how am I going to find the obtuse angle for this set? Alright, so I've just found this angle. That's the 42. So how am I going to find this angle for the other triangle? Nope. Because in the other triangle I can't find C yet. So I've just found this acute angle for this triangle that we can create. Right? But now I need to know what this obtuse angle is for this other triangle that can be created. So once I know this one is 42, how do I find that one? Exactly. Because remember, these two are the same, and so this one's got to be 180 minus whatever that angle was. So back here on our problem, if I find this one as 42, then this one is going to be 180 minus 42. And that's going to give us 138. Okay? So now, once I have the B's figured out for each of them, now I just figure out the rest of this one based on 42, and then I figure out the rest of this one based on the 138, and I figure out what my angle C and side C are for each case. So in this case, angle C should be what? 103. Because now if I have two angles, I just subtract from 180 to get the third. And then side C, what do I need to do for that?
Sine 35 equals to sine 103 over C.
Alright, so solve that one out. Got it? What'd you get?
20.38.
Okay. And then for my second triangle, if I do the same thing, what's angle C going to be this time?
7 degrees.
Okay, so same thing, 180 minus the 2 that I know gives me the 7 degrees that I'm missing. And then for side C,
2.5.
how much?
2.5.
2.5? So that's the second possibility. So these are the measurements of one possible triangle that I can make with these, and these are the measurements of the second possible triangle I can make with those same exact given measurements. And in order to get full credit, you have to tell me both. Okay? So that's the process you're going to kind of go through. First, decide if you're dealing with an SSA. If you are, then think about the 6 scenarios. Look at what kind of angle they give you first, because that'll tell you if you're talking about the 2 obtuse or the 4 acute. Okay? Then when you've narrowed that down, then take a look at how A and B and possibly H compare to each other. So if you're just doing the obtuse, you just have to decide between A and B. Is that opposite side bigger than B or smaller than B? If you're doing the acute, you can start by looking at A compared to B, the opposite side compared to the adjacent side. But if the opposite side is actually smaller, then you're going to have to find H and compare your opposite side to H. If you're smaller than H, there's no triangle. If you're the same as H, there's one. But if you're bigger than H and yet smaller than B, then you get the 2 triangle scenario. And then you work it out from there. Okay, so keep that paper close by when you do your homework so that you can be referring to it and thinking through which scenario is this triangle in, so that I know what, if anything, I need to solve. If there's no triangle, there's nothing to solve. You don't have to do anything. Just write no triangle and go on. Okay, does that make sense? Any questions? All right, so I'm pretty sure I have it posted. I think I got it posted yesterday. If not, I'll get it posted next period, but let's check here. Get into this pre-calc. So you'll see here, I have it labeled as, I don't have it up there yet. It's labeled chapter 5-6. It's called Additional Topics in Trig. At the moment, you can see I have the chapter 6. This is the chapter 6 textbook. These are the solutions. This is the chapter 5 textbook. These are the solutions. Okay? So those are all there, but I need to get your assignment up for you. So I'll do that in the next 10 minutes because I have a prep period next. I think it's actually in there. I just don't think I pulled it into the module yet. So I'll get that posted for you. Work on that for Monday. And then on Monday, we'll talk about law of cosines. And then we'll see how those two working together give us a lot of possibilities on the kinds of things that we can solve and work out and problems we can do and things like that. Okay? Okay, so you can go ahead and get packed up if you want. Just don't take off until the bell rings.